a tiny speck moves across the vastness of space. It's been traveling for possibly over 7 billion years. On July 1st, 2025, a telescope in Chile catches it, 4.5 astronomical units from the Sun, 3.5 from Earth, moving at 137,000 miles per hour. The Atlas Survey Telescope in Rio Hurtado reports it to the Minor Planet Center at 7:48 Coordinated Universal Time. Temporary designation A11PL3Z. Within 6 hours, astronomers at the Zwicky Transient Facility find it in their archive. June 28th, June 29th. Pre-discovery images, then June 14th. 3 days of observations becomes 17 days. The orbit calculation changes everything. Not elliptical, not parabolic, hyperbolic. Eccentricity 6.139. Higher than 1 I Oumuamua's 1.2. Higher than 2 I Borisov's 3.4. This thing came from outside. The third confirmed interstellar object ever detected passing through our solar system. They name it 3I Atlas. Also, this script is researched and factual, using sources from NASA Science published December 2nd, 2025, the European Space Agency's Planetary Defense Coordination reports, Wikipedia's continuously updated 3I Atlas article last revised 2 days ago, and peer-reviewed papers from Archivo, including Eubanks and colleagues' August 21st, 2025 trajectory analysis with 2,600, 11 observations from 177 observatories. Now back to the information. On July 2nd, 3 observatories confirm activity. Deep Random Survey in Chile, Lowell Discovery Telescope in Arizona, Canada, France, Hawaii Telescope on Mauna Kea. They all see a marginal coma, tail-like elongation, 3 arcseconds angular length. It's a comet, not an asteroid. Active nucleus, icy core releasing gas and dust. The Minor Planet Center assigns the interstellar designation, 3I, third interstellar object. Alternative name, C 2025 N1 Atlas. By the time they officially name it, 122 observations from 31 different observatories are logged. David Jewett and Jane Liu used the Nordic Optical Telescope on July 2nd. Clearly active, diffuse appearance confirmed. Built to find planets around other stars. Between May 7th and June 2nd, TESS caught 3I Atlas, 55 days before discovery. The comet was too faint for individual 200-second integrations, magnitude 20.9, so researchers stacked images. Aperture photometry on combined frames, 15 measurements, with signal-to-noise ratio above 3, collected across 26 days on 2 different TSS cameras. The brightness increased from T magnitude 20.9 plus or minus 0.29 to 19.57 plus or minus 0.15. Absolute magnitude decreased from 14.3 plus or minus 0.4 to 13.7 plus or minus 0.3. Signs of faint activity even that far out. 4.51 astronomical units from the Sun when discovered, already showing a coma. Hubble space. Telescope swings into action. July 21st, 2025. 3I Atlas is 277 million miles from Earth. 3.83 astronomical units from the Sun. Hubble reveals a teardrop-shaped cocoon of dust, coming off the solid, icy nucleus. Background stars streaked because Hubble tracked the comet moving along its hyperbolic trajectory. Observations continue through August 20th. The nucleus diameter, not less than 1,444 feet, not greater than 3.5 miles, somewhere between 440 meters and 5.6 kilometers. Mass loss rate calculations, size constraints that will guide every subsequent observation. David Jewett at UCLA leads the analysis, published in Astrophysical Journal Letters, volume 990, L2. Over 30 research papers in the AAS journals alone follow. Scientists scrambling to understand where this thing came from. Velocity at infinity, 57.976, 3 plus or minus 0.0044 kilometers per second. Solutions with different datasets all converge within a few tens of meters per second of 57.98, transform the velocity vectors into galactic UVW coordinate components. Yi Yang Guo and collaborators publish September 3rd, 2025, Search for Past Stellar Encounters. 3. I-Atlas may have passed within 1 parsec of 25 known stars in the past 10 million years, 3.3 light years. Which star system launched it? Unknown. But the properties reveal clues. If it's a thick disk member, the parent star could be a low metallicity star. Heavy element abundance at least 40% of the Sun's. Thick disk stars orbit above and below the thin galactic plane. They rotate a little slower about the galaxy. V component 14 kilometers per second smaller than thin disk. All 3 known interstellar objects share this slower galactic rotation. Matthew Hopkins at the University of Oxford publishes Analysis, the Otautahi Oxford model. Predictive modeling suggests 3I Atlas is the first known ISO from the Milky Way's thick disk. Not the thin disk where most stars orbit, not the halo, thick disk. Population of older stars. If correct, this comet may be over 7 billion years old, older than our solar system. Chris Lintott, Oxford astronomer, says there's a 2/3 chance this comet is older than the solar system. Been drifting through interstellar space ever since formation. Material untouched since another star's planetary disk condensed billions of years ago. Observations from Earth-based telescopes after sunset. Mid-July, located in Sagittarius. Apparent magnitude 17.5. Second half of July, moved to Ophiuchus. Brightened to magnitude 16. Psyche spacecraft passes 0.302 astronomical units from 3I Atlas on September 4th, 45.2 million kilometers, 28.1 million miles. Marshall Eubanks calculates the trajectory. Psyche observes the comet over 8 hours on September 8th and 9th. 4 observations captured. Europa Clipper mission observes on November 6th from 102 million miles distance. Lucy spacecraft, on its way to Trojan asteroids, spots it from 240 million miles. Stereo mission from September 11th to October 2nd. MAVEN's ultraviolet instrument images hydrogen atoms surrounding the comet. Punch mission observes during passage through inner solar system. Combined images show the comet's tail as short elongation, between 231 and 235 million miles from Earth. Between October 1st and 7th, the Mars probe gets about 10 times closer than telescopes on Earth. New viewing angle, triangulation of data with Earth observations. The trajectory prediction improves by a factor of 10. Scientists initially anticipated modest improvement. Result is impressive 10-fold leap in accuracy, reducing uncertainty of the object's location. The CASIS instrument designed to point at Martian surface in high resolution, now repurposed, accounting for the spacecraft's exact location at Mars, fast orbit around the red planet, flight dynamics teams, science teams, instrument teams, combined effort across ESA divisions and partners, planetary defense practice, even though 3I Atlas poses no danger, traveling up to 250,000 kilometers per hour, will soon vanish into interstellar space, never to return. The improved trajectory allows astronomers to aim instruments with confidence. Multiple spacecraft at Mars, potentially catching glimpses. The close approach data floods in. Spectroscopic analysis. High proportion of carbon dioxide relative to water ice in the coma. Presence of nickel-rich gas. Signatures of carbonaceous material. Formation in an ancient planetary system confirmed. Sphere X observatory collects data for about a week. Pre-perihelion mapping of water, carbon dioxide, and carbon monoxide. Published by Lisa and colleagues December 8th, 2025. JWST observations with near-infrared spectrograph instrument. Rich in carbon dioxide. Suggests formation far from parent star, beyond the carbon dioxide frost line. Temperatures cold enough for carbon dioxide to condense into solid ice. University of Hawaii 88-inch telescope. Spectrophotometric blue-sensitive spectral time series spanning 2 months from discovery. Hoogendam and colleagues, December 9th, 2025. JCMT constraints on early time HCN and carbon monoxide emission. Hinkle and colleagues, December 1st. ALMA Atacama Compact Array maps methanol and HCN. Remarkably high methanol to HCN production rate ratio. Distinct outgassing behaviors. Roth and colleagues, November 25th. October 29th, 2025. 11:44 Coordinated Universal Time. Perihelion, closest distance to Sun, 1.36 astronomical units. 203 million kilometers, 126 million miles. Between Earth's orbit and Mars, moving at maximum speed, 68 kilometers per second, 42 miles per second with respect to Sun. The comet passes behind the Sun from Earth's viewpoint. Observations pause, too close to solar glare. Reappears early December on the other side. Observations resume October 31st. Pre-dawn sky, Atlas photometry, Tunry and colleagues, September 5th. Extreme negative polarization, Gray and colleagues, September 5th. Follow-up observations of dust fan ejected, Ivanova and colleagues, September 5th. Tracking activity through perihelion, Eubanks and colleagues, November 25th. Water production peaks, Solar and Heliosphere Observatory, SOHO, orbital position 1.5 million kilometers from Earth. Swan camera watches hydrogen atoms, specific wavelength ultraviolet light, not designed to look at Sun. Maps hydrogen scattered throughout solar system. Catches 3, I-Atlas after perihelion, water production between 10 and 20 trillion molecules per second by early December. About 40 days after perihelion, decrease follows pattern recognized from solar system comets. Reduced heating farther from Sun, less ice sublimates from nucleus. Activity winds down, technique developed over 2 decades. Refined through observations of more than 90 different comet apparitions. combines swan hydrogen measurements with daily solar ultraviolet output readings, corrections for sun's rotation. Fluorescence rate depends on ultraviolet emission at a given moment. 39.8 million miles. Challenging thermal conditions during travel through inner solar system, using high-gain antenna as heat shield. Data transmission not expected until February 2026. Team downloads quarter of navigation camera image. Reveals active comet. Mid-November magnitude borderline between 10 and 9. Detectable in tripod-mounted 20 by 80 binoculars. Physical research laboratory scientists conduct observations from 1.2 meter infrared telescope on Mount Abu. Further spectrometry. The comet grows dimmer. Solar elongation increases, moving away from sun. Opposition 177.6 degrees won't occur until January 22nd, 2026. Much fainter by then. December 19th, 2025. Closest approach to Earth, 1 a.m. Eastern Standard Time. 6 a.m. Greenwich Mean Time, 1.798 astronomical units, 269 million kilometers, 168 million miles. About 8 times average Earth-Sun distance. Inside asteroid belt. Beyond 4-1 Kirkwood Gap. Green Bank Telescope observes less than 24 hours before closest approach. December 18th, 100 meter steerable single dish. Largest in world, 4 receivers, L, S, C, X bands, spanning 1 to 12 gigahertz. Sensitivity to transmitters with equivalent isotropic radiated power approximately 0.1 watt. Breakthrough. Listen observations, Allen Telescope Array early July. Meerkat Telescope detects hydroxyl signatures, expected as sunlight breaks down water ice. Blue's computer searches for technosignatures. No artificial radio emission detected. Limit 0.17 watts over 900 to 1670 megahertz range. Power output of mobile phone handset at distance to 3i Atlas. Murray-Young Park's radio telescope. Ultra-wideband low receiver, 704 to 4032 megahertz. July 31st, September 12th, October 5th. Expected sensitivity around 5 watts. No technosignatures detected in any searches. Object continues to behave as expected from natural astrophysical processes. 0400, Greenwich. December 20th, weather permitting. Glimpse before gone forever. National Geographic coverage. Satoru Murata. New Mexico-based photographer snaps photo November 16th, long tail. Secondary anti-tail. Distant galaxy in background. Constellation Leo. Near brightest star Regulus, not visible naked eye or weaker binoculars. Best bet through telescope, backyard or local observatory. Skywatching apps pinpoint location. East Coast easiest to spot pre-dawn hours. Highest in sky then. Plate-solving smart telescopes with aperture diameter at least 3 to 4.5 inches, 7.6 to 11.4 centimeters. See objects much fainter than visual observers. January 1st, 2026. Expected magnitude plus 15.6. Best suited imaging setups. Within reach. Smaller smart telescopes. Late December near Regulus. Westward path toward Cancer. January 1st. Approximately 2.5 degrees north of magnitude plus 3.5 Omicron Leonis. 20 degrees above eastern horizon at 2200 coordinated universal time. Reaching 52 degrees altitude when due south at 0300. Passes just under 4 degrees north of magnitude, plus 6.9 M67 on nights of January 11th, 12th, and 12th to 13th. Could be magnitude plus 16. January 16th at magnitude plus 16.3 passes 3.5 degrees south of M44. End of month not far from Jupiter. As of January 10th, magnitude around 13. Located in Cancer. Removes circularly symmetric halo around nucleus. Reveals triple jet structure. Major anti-tail jet oriented towards sun. 2 additional minor jets, equally separated in angle from each other and anti-tail. Sunward jet tightly collimated. Anti-tail extends approximately 400,000 kilometers. Earlier Hubble images, July 21st, also showed elongated structure pointing towards sun. Apparent length more than 11 times width when corrected for viewing angle, 11.6 times. Sunward orientation contrasts typical cometary tails. Most extend away from sun, solar wind influence on gas, radiation pressure on dust, but 3i Atlas has anti-tail. Consistently visible multiple images, different viewing angles, several months. Measurements suggest stable orientation during observation period. Consistent collimation and direction despite variations in distance from sun. Rotation axis aligned within 7 degrees of sun at large distances. Combined geometry, anti-tail, and rotational alignment documented. Ivy Loeb at Harvard reports findings on medium January 9th. Larger than expected particles detected in jets facing sun challenges standard sublimation models, suggests unique surface processes in cometary nucleus. January 22nd, 2026, 1300 coordinated universal time, Rare alignment. Earth passes nearly between Sun and 3I Atlas. Phase angle between Sun object axis and Sun Earth axis reaches 0.69 degrees. Unprecedented near opposition alignment for interstellar object. Unlike typical cometary opposition geometries lasting hours, 3I Atlas maintains phase angle below 2 degrees, approximately 1. Week, January 19th through 26th. Avi Loeb and Mauro Barbieri publish research note, January 12th. Based on JPL Horizon's trajectory, comet at distance 3.33 astronomical units from Sun, distance approximately 2.35 astronomical units from Earth. Opposition surge, brightness increase observed when phase angle approaches 0. Previous interstellar comet 2, Borisov never observed below 16 degrees phase angle, far outside opposition surge regime. Most solar system comets lack comparable data, larger minimum phase angles. Measurements during January alignment can address dust composition through albedo estimates, assess grain structure through surge width. Is dust dominated by carbonaceous material? Low albedo around 0.03. Or retain significant ice fragments, high albedo 0.1 to 0.3. Are grains compact, thermally processed, or fluffy fractal aggregates, pristine molecular cloud material? Research note recommends observations spanning at least 4 days before and after January 22nd. Phase angle remains below 2 degrees. Photometry with relative precision near 0.03 magnitude per data point. Consistent apertures. Background subtraction. Multiband photometry across 3 broadband filters. Wavelength-dependent analysis. Polarimetric measurements near minimum phase angle. Additional constraints on scattering. Telescopes exceeding 1 meter aperture indicated for photometry. Larger apertures for polarimetry. Coordinated observations across sites improve temporal coverage. Institutions on several continents plan observational campaigns. Networks professional and amateur telescopes. Broad temporal sampling. Narrow but well-defined observational window. Maximize scientific return community observations. 2026 alignment may not repeat for decades. Current event especially valuable. 33.3 million miles. Much closer to Jupiter than to Earth. Spacecraft stationed at Jupiter. Juno orbiter may observe. Unlikely Juno redirected. Low on fuel. Engine issues. 3 sigma uncertainty in object's position, plus or minus 1,030 kilometers at close approach. After Jupiter encounter, continues accelerating away from solar system. March 16th passes Jupiter. Trajectory tilted 175 degrees retrograde. Inclined 5 degrees with respect to ecliptic. Orbital plane closely aligned with solar system planets. Coincidentally, hyperbolic trajectory appears relatively straight rather than curved. Extreme eccentricity. By 2027, 16 astronomical units from Sun. Estimated magnitude 24. Year later, 2028, 28 astronomical units. Even weaker brightness. Crosses orbits Saturn, Uranus, Neptune by 2028. Heads to interstellar space. 57.98 kilometers per second. Relative to Sun, not bound by solar gravity, simply passing through. Trajectory traced backward into distant past. Traced forward into distant future. Never to return. One-time visitor, material from another star system. Snapshot of planetary formation elsewhere in galaxy. Composition behavior compared to solar system formation. Diversity planetary systems throughout galaxy. Water mass, fraction predictions. Hopkins and colleagues suggest unusually large size, perhaps as large as 6 miles, 10 kilometers, up to 10 times larger than 2I Borisov. Even more compared to 1I Oumuamua. Unexpected size suggests population interstellar objects may include more large bodies than previously thought. Rosemary Dorsey, University of Canterbury, Christchurch, New Zealand. Discovery of 3. I suggest prospects for Rubin may be more optimistic, may find about 50 objects, some similar in size to 3I Vera C. Rubin Observatory. When operational, increased detection capabilities, more interstellar visitors, statistical sample grows. ExoMars 10-fold trajectory improvement from Mars orbit. TESS, pre-discovery images, extending timeline by 55 days. Psyche, Lucy, Europa Clipper, Maven, Stereo, Punch, all contributing pieces. Breakthrough Listen, technosignature searches establishing natural origin, ground-based telescopes worldwide, Atlas photometry, extreme polarization measurements, dust fan tracking, activity monitoring through perihelion, water production, decline post-perihelion, methanol HCN mapping with ALMA, University of Hawaii spectral time series, JCMT emission constraints, physical research laboratory, Mount Abu infrared observations, virtual telescope project public live streams, amateur astronomers, plate-solving smart telescope images, international collaboration, 177 observatories, 2,611 observations. May 7th through August 12th, initial orbital solution. Pre-discovery extending back to May 15th. Root mean, square residuals, 0.521 and 0.626 seconds, arc right ascension and declination. Precision improving with each observation. January opposition alignment providing unprecedented phase angle coverage. Community coordinating photometry, polarimetry campaigns. Maximizing scientific return narrow window. 4 days before, after January 22nd, filters wavelength analysis, scattering constraints, grain structure composition. If halo object, particularly intriguing. Potentially relic population 3 star formation, galactic kinematics analysis, UVW coordinate components, chi-squared for 3 degrees, freedom 7.9, 95% probability limit, weak but positive confirmation, thick disk membership, mean U and W polar velocities near 0, both thin and thick disk. Magnitudes indicate which disk ISO comes from. Biggest mean component difference, thick disk rotates slower. V component 14 kilometers per second smaller. All 3 known ISOs share slower rotation. Scatter in V velocities larger than difference. Significance bias unknown until more ISOs discovered. Velocities analyzed, statistical framework developing. Goal: located between Sun and Earth. Detect near-Earth objects coming from Sun's direction. At least 3 weeks. Advance potential Earth impact. Comet interceptor mission in development. Following Rosetta footsteps. Landed comet 67P in 2014. Next generation comet mission. First to visit comet coming directly from outer reaches, Sun's realm, carrying material untouched since dawn solar system. Possible though, very unlikely, given rarity could visit interstellar comet. Icy wanderers offer rare tangible connection, broader galaxy. Actually visit one would connect humankind to universe far greater scale. 3. I Atlas tangible. Documented. Tracked from discovery through solar system passage. Pre-discovery to post-perihelion. Mars, Venus, Jupiter flybys. Earth closest approach December 19th. Opposition alignment January 22nd. Every spacecraft, every telescope, every observatory contributing. Global effort, planetary defense practice, scientific opportunity, understanding another star system's planetary formation, 7 billion years old material, thick disk origins, carbon dioxide rich, methanol through HCN ratios distinct, anti-tail sunward jets, triple structure, stable rotation alignment, larger than expected nucleus. Hyperbolic trajectory eccentricity 6.139, velocity 57.98 kilometers per second. Never seen before, never see again. Polarization properties, JWST data analysis, orbital refinement, pre-discovery data mining, parent star search, stellar encounter modeling, composition spectroscopy, outgassing behavior, jet morphology, nucleus size estimation, activity tracking, water production rates, dust grain analysis, opposition surge preparation, observational campaign coordination, every angle covered, every instrument utilized, every opportunity maximized. Interstellar visitor from thick disk, older than solar system, traveled light years, passed 25 stars within 1 parsec, last 10 million years. Which one launched it? Unknown. Properties inferred. Low metallicity star, 40% sun's heavy elements minimum, protoplanetary disk, gas, and dust, surrounded parent star when young, formed beyond carbon dioxide frost line, cold temperatures, solid ice condensation, preserved billions years. Drifting interstellar space until now. Formation conditions, other star systems. Planetary system architectures, galaxy-wide. 3I Atlas III confirmed. How many undiscovered? How many missed passing through before detection capabilities? How many will we catch next decade? Rubin projections, 50 objects. Some 3I size, some larger, some smaller. Active comets, inactive asteroids, fast movers, slow drifters, thick disk, thin disk. Halo, each one unique window. Each one tells story, planetary formation elsewhere, material processing, survival, interstellar environment, radiation exposure, cosmic ray bombardment, galactic tidal forces, stellar perturbations, millions years, billions years. Then brief passage, inner solar system, months observation window, weeks peak activity, days optimal geometry, hours critical measurements, minutes telescope pointing, seconds exposure integration, every photon counts. Opposition. 22, January 1300, UTC, phase angle 0.69 degrees. Earth between Sun and comet. Sunlight travels to comet, reflects back, travels to Earth. Minimal scattering angle. Brightness enhancement. Opposition surge. Dust particle properties revealed. Albedo, reflectivity. Composition indicators. Carbonaceous low, icy high. Grain structure, compact versus fluffy. Thermal processing versus pristine aggregates. Parent disk conditions. Temperature regime. Chemical inventory. Radial distance from star. Age of system. Metallicity of star. All encoded in dust properties. all measurable during narrow window, all dependent on coordinated observations, all requiring precise photometry, 0.03 magnitude precision, multiple filters, wavelength coverage, polarimetry measurements, scattering geometry, surge amplitude, surge width, models fitted, parameters constrained, questions answered, or new questions raised. Science advances, understanding deepens. Stellar encounter, planetary migration, giant planet scattering. Something launched it, something gave it escape velocity, something sent it into interstellar space, traveled through galaxy, past stars, felt their gravity, slight deflections, velocity changes, direction shifts, integrated over time, over distance, until solar system, until sun's gravity well, until hyperbolic trajectory bent inward, until perihelion, October 29th, until outbound now, until Jupiter March, until beyond, until interstellar space again, until next stellar encounter, millions years future, billions years future. If survives, if doesn't fragment, if doesn't collide, if radiation doesn't erode too much. Big if. Brightness fluctuations, morphology changes, fragment detection attempts, so far intact, so far single nucleus, so far holding together, triple jet structure stable, anti-tail persistent, activity declining as expected, water production dropping, distance from sun increasing, temperature decreasing, sublimation slowing, coma shrinking, tail shortening, fading from view, magnitude increasing, brightness decreasing, harder to observe, larger telescopes required, longer exposures needed, January 16 magnitude, 16.3, end January near Jupiter, February fainter still, March Jupiter flyby. After that, rapidly dimming, spring 2026 last observations, then too faint, then gone, then interstellar space, then just calculations, then just memories, then just data, then just papers, then just history. Third interstellar object confirmed. First thick disk origin, first with opposition alignment, first with anti-tail documented this extensively, first with pre-discovery test data, first with Mars orbit trajectory refinement, first with this many spacecraft observations, first with this level community coordination, first with January 2026, timing allowing unprecedented measurements, first with methanol HCN ratios this high, first with carbon dioxide this prominent, first possibly 7 billion years old, first with potential population 3 connection, first with Rubin observatory implications, first suggesting 50 more detectable, first proving detection infrastructure works, first demonstrating global coordination succeeds, first showing what's possible, first indicating what's coming. Technology improving, sky surveys expanding, cadence accelerating, magnitude limits deepening, more objects inevitable, more interstellar visitors, more one-time passages, more opportunities, more questions, more answers, more understanding, more appreciation, complexity, more recognition diversity, more humility facing galaxy, more wonder at universe, more drive to explore, more missions planned, more instruments designed. More observations scheduled, more coordination developed, more infrastructure built, more capability enhanced, more readiness improved, more preparation invested. So next time, better, faster, deeper, longer, more complete, more thorough, more comprehensive, more exhaustive, until catalog grows, until statistics meaningful, until populations defined, until origins traced, until mechanisms understood, until galaxy mapped, until formation histories revealed, until we know, until we understand, until we see. Not just 3, dozens, hundreds, thousands, everyone telling story, everyone from somewhere, everyone going somewhere, everyone briefly here, everyone never returning, everyone precious, everyone unique, everyone opportunity, everyone teaching us about out there, about galaxies, about stars, about planets, about formation, about evolution, about chemistry, about physics, about time, about space, about motion, about gravity, about light, about matter, about origins, about futures, about them, about us, about where we come from, about where we're going, about being small, about universe vast, about brief moments, about eternal journeys, about catching glimpses, about never forgetting, about documenting everything, about understanding what we can, about accepting what we can't, about trying anyway, about looking up, about seeing, about knowing, about caring, about preserving, about sharing, about continuing, about never stopping. Aperture, consistency mandatory, filter sequences planned, exposure times optimized, signal to noise target set, data quality monitored, real-time adjustments, telescope tracking verified, guiding stability confirmed, seeing conditions assessed, atmospheric transparency measured, extinction coefficients calculated, standard stars observed, 0 points determined, color terms derived, systematic errors minimized, random uncertainties quantified, statistical confidence established, results compiled, analysis begins, models fitted, parameters extracted, uncertainties propagated, comparisons made, literature consulted, theories tested, hypotheses evaluated, conclusions drawn, papers drafted, revisions made, submissions prepared, reviews awaited, publications anticipated, knowledge advanced, field progressed, understanding enhanced, community enriched. Just physics, just chemistry, just motion, just being, just existing, just traveling, just reflecting sunlight, just sublimating ice, just releasing gas, just ejecting dust, just following Newton, just obeying gravity, just conserving momentum, just radiating thermal, just absorbing solar, just spinning, just processing, just aging, just changing, just being what it is. Chunk of ice and rock and dust and organics from another star system 7 billion years ago, now passing through ours, now being measured, now being documented, now being understood, now being appreciated, now being remembered, now being added to catalog, now being numbered third, now being named Atlas, now being studied, now being published, now being discussed, now being taught, now being learned, now being known. Maybe approaching or already past, missed, too faint, wrong sky coverage, bad timing, or future. Years away, decades away, but coming. Statistically, population density, galactic environment, ejection rates, travel times, encounter probabilities, detection windows, survey capabilities, discovery rates, predictions, 50 from Rubin, time frame, next decade, maybe. Uncertainties large, but prospects improved. 3, I exists. Detection confirmed, infrastructure validated, methods proven, coordination demonstrated, capabilities verified, readiness established when next arrives. We'll be watching, we'll be ready, we'll point telescopes, we'll gather data, we'll coordinate globally, we'll measure precisely, we'll analyze thoroughly, we'll publish promptly, we'll learn collectively, we'll understand better, we'll appreciate more, we'll never forget, we'll keep records. We'll preserve knowledge, we'll pass forward, we'll build on, we'll improve, we'll advance, we'll progress, we'll evolve, we'll grow. From 3 objects to 30 to 300 to 3,000, eventually. Given time, given effort, given persistence, given coordination, given funding, given support, given interest, given curiosity, given drive, given humanity, looking outward, looking upward, looking forward, looking always, at what's out there, at what's coming here, at what's passing through, at what's telling us about universe, about ourselves, about connection, about isolation, about commonality, about uniqueness, about origins shared, about destinies separate, about brief encounters, about permanent records, about moments captured, about eternities suggested, about dust and telescope, about stories and data, about voices and spectra, about whispers from stars we'll never see, from systems we'll never visit, from times long past, from distances vast, from 3i Atlas, from interstellar visitor number 3, from object that was somewhere else when dinosaurs walked Earth, that traveled while mammals evolved, that crossed galaxy while humans emerged. That arrived July 1st, 2025. That passes January 2026. That leaves March. That continues beyond. That never returns. That we caught, that we measured, that we know, that we'll remember. 400,000 kilometers. Stable, collimated, persistent, different, unusual, teaching us about rotation, about outgassing, about nucleus shape, about surface features, about activity patterns, about material distribution, about thermal properties, about structural integrity, about formation history, about parent environment, about ejection mechanism, about interstellar journey, about radiation effects, about cosmic ray impacts, about dust accumulation, about ice preservation, about organic survival, about 7 billion years, about thick disk, about low metallicity, about older galaxy, about population 2, about maybe 3, about when stars form different, about when metallicity lower, about when galaxy younger, about when conditions distinct, about then, about there, about not here, about not now, about visitor, about messenger, about archive, about library, about data storage, about information carrier, about knowledge source, about teacher, about 3i Atlas. This dust, this gas, this nucleus, this coma, this tail, this anti-tail, this jet, this rotation, this orbit, this trajectory, this eccentricity, this velocity, this origin, this destination, this journey, this passage, this visit, this farewell, this never again, this once only this third confirmed, this first thick disk, this January 22nd, 2026, this 1300 UTC, this 0.69 degrees, this 3.33 AU, this 2.35 AU, this magnitude, this measurement, this observation, this coordination, this effort, this achievement, this science, this discovery, this understanding, this knowledge, this wisdom, this humility, this wonder, this appreciation, this gratitude, this privilege, this responsibility, this duty, this commitment, this continuation, this future, this legacy, this foundation, this beginning, not ending, this first of many, this third of thousands, this opening, not closing, this learning, not knowing, this questioning, not answering, this exploring, not arriving, this seeking, not finding, this journeying, not destination, this process, not product, this wonder, not certainty, this science, but never complete, never final, never certain, always provisional, always pending, always awaiting, next observation, next measurement, next object, next discovery, next surprise, next challenge, next opportunity, next lesson, next teacher, next visitor, next messenger, next archive, next 3i, next interstellar, next hyperbolic, next eccentric, next fast, next old, next different, next unique, next once, next never again, next documented, next measured, next known, next remembered, next teaching us about universe, about galaxy, about stars, about planets, about us, about them, about here, about there, about now, about then, about physics, about chemistry, about motion, about time, about space, about matter, about energy, about light, about gravity, about formation, about evolution, about diversity, about commonality, about uniqueness, about connection, about isolation, about together, about alone, about fleeting, about eternal, about small, about vast, about moments, about ages, about dust, about stars, about ice, about fire, about dark, about light, about knowing, about wondering, about 3i Atlas. Temperature still low, but activity detected. Sublimation started. Nucleus processing solar input. Surface heating. Subsurface warming. Ice phase transitions. Gas production initiating. Dust entrainment beginning. Coma formation starting. Tail development commencing. Earlier than expected, or exactly as predicted. Models calibrated. Parameters refined. Ice composition inferred. Thermal properties estimated. Nucleus structure suggested. Porosity indicated. Density constrained. Mass estimated. Volume calculated. Size confirmed. Between 440 meters and 5.6 kilometers. Albedo assumed. Geometry considered. Viewing angle corrected. Projection effects removed. True dimensions approached. Uncertainty quantified. Range established. Upper limit. Lower limit. Best estimate. Most probable. Given data. Given models. Given assumptions. Given physics. Given chemistry. Given observations. Given tests, given Hubble, given JWST, given SphereX, given all spacecraft, given all telescopes, given all observers, given all data, given all analysis, given all effort, given all coordination, given everything, we estimate, we constrain, we bracket, we approximate, we approach, we understand, partially, incompletely, but better than before, than yesterday, than last week, than July, than never, than ignorance, then assumption, then guess, now knowledge, now measurement, now data, now evidence, now science, now understanding, growing, improving, advancing, progressing toward better, more, deeper, clearer, truer. About 3i Atlas. When watching concludes, what remains? Data, archives, papers, records, knowledge, understanding, memory, appreciation, gratitude, wonder, questions, unanswered, for next, for future, for when. More objects, more data, more measurements, more comparisons, more statistics, more populations, more distributions, more correlations, more patterns, more understanding, more complete, more comprehensive, more thorough, more deep, building on. 3i. And 1i, and 2i, and 4i, and 5i, onward, growing, learning, understanding, advancing, together, globally, coordinated, collaborative, shared, open, transparent, documented, preserved, for everyone, for future, for always. 3i Atlas, interstellar visitor, thick disk origin, 7 billion years. Carbon dioxide rich, anti-tail sunward, triple jets, opposition January 22, never returning, never forgotten. Always known, always remembered, always teaching, forever. Physics learns. Chemistry understands dynamics, appreciates complexity, respects nature, honors reality, seeks truth, pursues knowledge, advances science, benefits. Humanity enriches understanding, expands awareness, deepens appreciation, cultivates wonder, inspires curiosity, motivates exploration, encourages investigation, supports research, enables discovery, facilitates learning, promotes education, shares knowledge, disseminates findings, publishes results, archives, data preserves, records maintains, legacy continues, tradition upholds standards, exemplifies excellence, demonstrates capability, proves worth justifies effort, validates investment, rewards dedication, acknowledges contribution, recognizes achievement, celebrates success, appreciates opportunity, honors privilege, respects responsibility, accepts duty, commits future promises, continuation, ensures persistence, guarantees advancement toward understanding of 3i Atlas and all that it represents and all that it teaches and all that it means for us, looking outward, reaching upward, striving forward, always learning, never stopping, until we understand not everything, but something more than before, more than yesterday, more than without, more than never, something real, something true, something measured, something known about interstellar visitor. Number 3, about comet from thick disk, about object 7 billion years old, about messenger from ancient star, about archive of distant past, about library of other formation, about teacher from elsewhere, about 3i Atlas, tracked from pre-discovery to post-perihelion from May through January, from TESS through Hubble from Mars, orbit to Earth, alignment from discovery to departure, from arrival to farewell, from first glimpse to last light, from beginning to ending, to continuation in data, in archives and papers and knowledge and understanding and memory and humanity forever,